Hi, y'all. Thanks for being here. We are in the ADI Books Deeper Dive. This is High School Earth and Space Science, and I am Krista Sampson. I will be moderating this webinar, and I am here with your presenter, Victor Sampson, and so I will let him take it away.
So on to the webinar. What we wanted to do is do a deeper dive into the High School Earth and Space Science book. Here's the table of contents in there, so you can kind of see the different investigations that are included. That we look at star clusters, characteristics of the universe, closest planet to Earth, which is a super interesting one that it has to do with orbits. The gorges at Thingvellir National Park in Iceland, increases in average global temperature, Arctic sea ice decline, reduction of atmospheric carbon dioxide, and a mine in Alaska, the Pebble copper mine. Today, I thought we would look at Arctic sea ice decline because that's actually in the news quite a bit of that. The rapid decline in sea ice has got a lot of scientists worried. So this is a pretty timely investigation here. So let me show you how this ends up working. So like all NDI investigations, we always start with a phenomenon. So this is the student handout for the Arctic sea ice decline investigation. What we do is we're going to show them a video of how the ice covers in the Arctic changes over time from year to year. What we do is as they watch the video, we encourage kids to write down things that they notice. After they do that, they can share out those ideas to the whole class. And then that's when we bring up the task is why do, in this case, they're trying to figure out why do scientists predict that the rate of global warming will increase if the amount of sea ice that covers the Arctic Ocean continues to shrink like it has been for a number of years. From that point, we ask kids to think about that. Like, why would less ice end up leading to greater or faster global warming? Ask them to try to write that idea out as a model. Then we have them show those models in their groups. And as they share those models, they start really kind of being faced with a lot of uncertainty, things they're not sure about. And that leads to a bunch of new questions. And those are all questions based on things that they're really curious about or would like to know more about. So then you have the students generate the list of those in their groups, and then they can share out. Really great way to get kids really interested in driving the investigation through their questions. What we also do with every book, every purchase of a book comes with a book code that you can do to add the investigations from your book into your library in our Learning Hub. And once you have those investigations in there, you can do a couple things. One, you can click on the investigation and download all the student handouts so you don't have to photocopy them off from the book. You can print them out in color and you don't have to worry about the binding issue where the book bends. But it also includes a presentation mode, and the presentation mode has all of the images and text that are on the handouts that allows you to basically use it as a slide deck as you're facilitating. So you can guide kids as they move along. So all of the text ends up having all of the content of the pages on the presentation mode match what's on the handout. So you can kind of read this aloud, have kids follow along, and it also has the videos embedded. So let me show you the video for this investigation. So you encourage kids to write down what the notice and to remind them about that. You can then also have them show this image here of share what you notice as you watch the video with the rest of your team. What's also nice is you can blow up the text on this to make it nice and large so everybody can see. And it's a really great way to keep everybody on the same page as they're moving through an investigation. As I mentioned before, at the end of the task stage, you've asked kids to come up with a bunch of questions that they have now about the phenomenon that they observe. This is, in this case, the sea ice decline. And you go about explaining that and why that would speed up global warming. So we now introduce some science ideas that they can use. And these ideas are the core ideas or the cross-cutting concepts that are pulled straight from the standards that the students need to know. So what we're trying to do is provide opportunities for students to use ideas to make sense of phenomena as much as they can. So in this case, we would start off with talking about the greenhouse effect. What is that? What does that look like? Usually when I'm working with students, especially the first time we do one of these, I just read this text aloud and have the class follow along. As I'm reading, I'll kind of call out things that might be important. That's interesting. Maybe put a star next to that. And then when I get through this kind of section, I have the groups of students work together to identify what they think are some useful ideas to help solve or figure out or answer the guiding question. They come up with groups, some useful ideas, and we share those out. You can record them on a master list in your classroom, and then they can make sure that they have a copy of all those ideas as well. So it really gives them some good practice about pulling out information, because not everything is is necessary at this point. From there, we move on to the idea of albedo, right? So we introduce that idea, same process, identifying useful ideas. And then we end with the idea of system models and how those can be used to test ideas and also bring up the ideas of limited precision, reliability, inputs, outputs, all of those different kinds of features. To support that process in the Learning Hub, we also, all the text is right there on the different pages of the screen. So you can click through this with a clicker and you can read it aloud right off the screen instead of having to hold up a handout. The other nice thing about this is you can click on any of these images and they blow up to full screen. So if kids are having a hard time seeing them, you can make them bigger or on their copies of their handouts if you're using those. Sometimes it's hard to see when things have been photocopied a bunch of times. They can then look at a color version of that that's nice and clear up front. So it's a really easy way to kind of draw attention to different things that they may miss when they're just reading them off on a handout. Once again, you have also the bubbles that we call the bubbles on the handouts that you can stop at and say, this is where I want you to fill out this information, write this stuff in the bubble on your handout. It just keeps everybody on the same page and makes it really easy to facilitate one of these investigations. After they've got some ideas, the ideas that we introduce won't answer all of the questions. So their questions are the main question of the investigation. So now they got to plan out an investigation to get the remaining information they need. In this case, they're going to be using a simulation that called the greenhouse effects that allows them to collect data about things about if they change the albedo or the brightness of the sun, adding clouds, those kinds of things, and start testing their ideas. In Learning Hub, we have this embedded so you as a teacher can set up the simulation, talk them through it, show them what it can do, not tell them exactly how to use it, but just how it works. Once you show them that, you can have them work in their groups and they can plan an investigation using that simulation. We include these graphic organizers to help them kind of think through what are you trying to figure out, what observations or measurements you need, how you're going to collect those, what are you going to do with them once you have them. Once you have that plan, or the groups have that plan, you can check it over. We usually recommend signing off on it and saying, hey, that's a good start. That becomes a nice check-in point. So you can make sure students are going to be going on the right path, so to speak. That way, because if they make mistakes when they're planning out something, you can give them some feedback before they get started. Nice little check-in point for them. The next stage is due. So what we do in the Learning Hub is we provide a URL for simulations. So if they're working on the simulations we have are free to access, that we use are free to access. They just require a web browser. So pretty much phone, tablet, computer, laptop, anything that will connect to the internet allows you to do that. So we provide a URL for them that you can show on the screen. They can get into that spot on their device. Once they're on their device, they can set up and use the simulation. And then on their handouts, they can collect data. So they can run trials, they can set up different inputs, measure the outputs, and then after they're happy collecting data, they can go ahead and make sense of it by analyzing them, looking for trends over time, difference between groups, relationship between variables. We provide this graphic organizer for them, not because they have to make a graph for everything, but in case they do, they've got some lines there that they can create that easier. Once every group has made sense of their data, they should have an answer to the guiding question. So they should be able to explain why scientists are concerned in this case. So then what we do is we have each group on a large whiteboard create an argument to share what they figured out. And so that argument includes the claim that they're making, the answer to the question, evidence, which is data that they've collected, then analyzed, and then provide an interpretation of that analysis, and then a justification of an evidence, which basically is, why does this evidence matter? Why did you decide to use that evidence to support your ideas? Once each group comes up with that argument, they can then share them out. There's many ways to do that. You can do kind of a gallery walk. You can do a modified gallery walk. You can use sticky notes. You can have them do it verbally. However it is, you're trying to get feedback to students. So to help them kind of use this feedback, we include this box on their handouts. So if they're at somebody else's board and looking at that and they see a great idea, maybe a way of representing their evidence, they can write that down and bring it back to their group to talk about it. Or maybe if they're presenting their argument to another group and someone gives them direct feedback, they can write that down about an idea of what to change and make it better. At the end of this stage, you want to make sure the kids have enough time to actually change their arguments. It's another reason why you do them on whiteboard, so it's really easy to change them. So they should have a final argument at the end of this process. To help them with this kind of task, because kids are often novices about what counts as evidence or what we mean by a justification, we include some extra supports in the Learning Hub that you can put up on the screen to help remind them what goes where. From there, you want to bring all the groups in together and have a whole class discussion about the core ideas that they were using, and as well as how to engage in the practice of science in more nuanced ways over time. So how we recommend doing that is first focusing on the core ideas. In this case, the core ideas were the greenhouse effect and albedo. So if you think about how those work, if you show a graphic like this, which is a model, asking kids to use their ideas about the greenhouse effect and albedo to explain what's going on in there. Right. And then there's little labels of letters that makes it easy for them to say what point B or D or C or E. So they can kind of talk through that. Have each group kind of talk amongst themselves how they would explain what's going on in the image. Then they can share out. You can have other groups then add on, disagree, those kinds of things, get a really good discussion going. You can also take that time to reteach if you need to, and clear up any kind of misconceptions that they may have at this point. Then you can move on to how to engage in the practices in more nuanced ways. We include these kind of these discussion starters. So the first one is what you do kind of well. So in this case, what you do is you carry out your investigation to increase your confidence in the quality of your evidence. You relied on to make or support a claim. So really everything is about evidence in science. So how do we be sure that our evidence is of high quality? What things did you do? What would you have done differently to improve the quality of the evidence? And then what should we do in the future to plan and carry out the best investigation possible? I love this question because students can kind of come up with rules for themselves. Or, okay, next time I'm going to do this. Next time I'm going to make sure to do this. To keep track of that, we also include on their handouts a place for them to write down ideas to their future self. This is where they can write down anything they want to remember about the core ideas or anything about the practices of science that they need to keep in mind. If you're having students generate class rules, you can have them write them down here and refer back to this during the next investigation. Finally, at this point, students have been working in either small groups or in a whole class setting the entire time. So we will now want to give students each as individuals an opportunity to think about the content, and write about it. And by writing about it, it does two things. One, it makes them really have to think about what they're saying, which helps them solidify their ideas. And it also helps them learn how to communicate in a more scientific way. This is not supposed to be a huge, long project, a 10-page paper or anything. It's basically one sheet of paper, two sides, a three-part report where it has an introduction of what you're trying to figure out, method, how you went about doing that, and then your argument. You're taking the ideas of your group that were on your whiteboard that you finalized, and then turning that into a text that you can share your ideas with others. So every student writes out a report. We include these sentence starters to get started. I would not recommend using these past one or two investigations, especially at the high school level, but this is pretty nice when you're just first getting started of like, what do you need for me in these spots? And it's much less scary than looking at a blank page. Once every student has wrote a report, you do a peer review process of that. So here's how I recommend doing that is I would put students in groups of 3 to do the review. So to say you have a class of 30 kids, you would divide them into 10 groups of 3. Okay, so sit those 10 groups in little pods. Then give each group a peer review guide, which is on the screen here, and a report written by somebody outside of that group of 3. Then you give them 15 minutes as a team to read through that report and then fill out this peer review guide. And basically they go through the questions that are in each section that correspond to the different part of the report and the writing mechanics. If they answer the question with yes, they think it's perfect. If they answer with no or somewhat, they need to give the author some feedback. So they fill that out. You give them 15 minutes to do that. At the end of 15 minutes, you collect that report and the peer review guide. Then you give each team a new report written by somebody outside their group and a new peer review guide. You can have a different student be the recorder now for the group, which works really good. Another 15 minutes to review that one. At the end of 15, collect that report and peer review guide, and then hand out one more report and one more peer review guide, ask for a new recorder, and finish that out. So at the end of 45 minutes, you have had all 30 reports reviewed by another group. And each group has done 3 reviews. Each group has had a different recorder each time, and each one has seen different ways of talking about the content and how to write. Works really well for improving writing skills and actually thinking about the content in more nuanced ways. After all of these are reviewed, make sure that the original author gets their report back and the peer review guide. They can take it home and then rewrite how they need to make it better. Once again, you can give them the same handout with the sentence starters. You can ask them to type it up. You can ask them to handwrite it on a blank sheet of paper. However you want to do it, it's completely up to you. But then after they're done revising their report, they can turn in their first draft and the peer review guide that they got back that was filled out by their peers. And then you can use the exact same peer review guide, but this time you can use it as a rubric to grade the report. And you can just go down each of those questions and give them a score there. And what ends up being really nice is these look really good toward the end of that because they've actually looked at the grading criteria, they've seen examples, and they've had a chance to make corrections. And for you get to give them a nice grade at the end and say good job on what you've done. So that's how the investigation goes. If as we're going through this, you're probably thinking, wow, that was a lot. What we try to do is include really useful lesson plans for all of this. So here's the images of the lesson plan that you can find in this, that goes with this investigation. It always starts off with an overview of what students are figuring out, what the guiding question is. Then it has a graphic that shows you how you can break up the 7 stages of an ADI over multiple days. And we usually think of it about kind of 50-minute periods is how we write this graphic. Then there's your standards alignments, what's your performance expectation, core ideas, the WIA English Language Development Standards for Science, and the Common Core English Language Arts are all in there. We also include things about the core idea, the cross-cutting concepts in science and engineering practices that you should know as a teacher to help guide students through those reflective discussions. We also include detailed lists about the materials, and if we're using a simulation, a detailed explanation about how you use that. So you can use this to kind of learn how to use it, and then you can show students from there. And then most importantly, for each stage of an investigation, there are multiple activities that go on within each of that stage. So what we did is we divided the lesson plan by those activities to make them easier to digest and find. So on this screen here, you can see the first two activities for the task stage, and includes what you do during that activity, what you give out, what to show, about how long it should take. It also includes teaching tips, which are usually advice on classroom management, and then boxes that are labeled attending to equity, which gives hints and tricks that you can use to help support different students that need extra support. So things like how you can help struggling readers or students who are learning, just learning English and engaging in this practice, or how you make sure that kids feel comfortable sharing ideas. So all of these kind of different things. So with that, that's kind of the deep dive into the high school Earth Space Science book. If there's any questions, feel free to click on Q&A and type them in there, or you can just click the raise your hand button and we can call on you.
And it comes from Tasha. What do you do when students collect inaccurate data or make mistakes during the investigation? Do you let them start over or use what they have?
Oh, that's fantastic. So what we recommend doing is treating it just like science, right? So when you are in science, you do your best to collect accurate and reliable and valid data, right? Because we make all of our decisions based on that. However, sometimes we make mistakes. So what ends up happening, what's important is realizing, being able to identify a mistake, A, and then B, from there, what do you do with that? So what kids will often, like what I used to do when I was a teacher, is I would say, hey, don't use that data, use this, or I would make up something for them to get the right conclusion. And that's basically teaching them to fudge data. So what instead you ask them to do is, can you explain why your data is faulty in some way? And if they can say yes, then you say, don't use that. And either, if you have time, recollect or redo your tests, which are super to do on a simulation like this, or they can decide to share data across groups and use the ones that they're more confident in. So it's kind of your call on what you push kids to do, but it's really important for them to understand that the ultimate arbitrator of all these ideas is evidence, and our evidence is only as good as the data we collect, our choice of analysis, and how we interpreted it. So understanding if there's a flaw in it is really important.
Excellent. And looks like we have another question from Chris. How do you help students who struggle with academic vocabulary while writing their final reports?
So that's one of the nice things about how this is all built in. There are so many opportunities to kind of earn your use of words. So instead of starting off with a list of definitions where students can't really make sense of that definition, say like photosynthesis or albedo for that example, you can teach kids to break the words down, but that doesn't really help. Instead, what we're doing is having them use these concepts as they're going and being able to name them as a shorthand for that concept. So as you're studying albedo and you're designing investigations around albedo, you're seeing that that's changing the darkness of a surface, right? Or the reflectivity of a surface. And based on all those experiences, by the time you get to the end, when you're writing about it, you've already talked about it, you've already collected data on it, you've drawn pictures about it, you discussed it and you debate it, you've earned that word, so to speak. So really, it's just kind of going through the process and they know the words by the end of it.
Excellent. That looks like that's all the questions we have for today. So I will hand it back to you, letting everyone know what's coming up.
Fantastic. So we're finishing our deep dives this week. Tomorrow we will be looking at biology from 4 to 4:30. Then right after that, we'll dive into chemistry from 4:30 to 5. Then on Wednesday, we're going to look at we'll look at the physics books from 4 to 4:30. And then we're actually going to end it with a course that's specific to Texas called IPC, which is Integrated Physics and Chemistry. Kind of talk about what that one looks like, because that's kind of a unique course that's not offered everywhere. So that's what we'll be ending with.
Awesome. Thanks so much. And thanks for joining us. Have a wonderful evening.